This is part one of operations with rational expressions. So operations just means adding, subtracting, multiplying, and dividing. Rational expressions are just fraction expressions. So this tutorial covers only the multiplication and division of fraction expressions. Let's just do a small review before we get into the problems. So here's a review on the multiplication of fractions. Here are two fractions that are multiplying each other. You could always just multiply the tops and the bottoms and then break it down to lowest terms. This is fine if you have small numbers in your original fractions, but if your fractions are quite large, it's going to be hard to multiply and then break down. So it might be a good idea and more efficient to break down first, then multiply. So to break down, you choose a numerator and a denominator that have a common factor. So both of these can be divided by 2, and that leaves 1 and 5. There's also another numerator and denominator that have a common factor of 3, so we divide them both by 3 and we get 1 and 3. Now that everything is broken down, you have smaller numbers, so when you multiply the tops, you get the lowest number right away. Okay? So let's use this information and we can then apply that to these rational expressions. So before we multiply, let's break down. The 20 can be broken down with the 35. Both can be divided by 5, and that leaves a 4 and a 7. Now the p's can also be broken down. You have 4 on the top and 2 on the bottom. So technically, if I canceled them out, I'd still have 2 p's on the top. The 9 and the 18 can both be divided by 9. You get 1 and 2. And then Q3 and Q2 can both be divided. And when I cancel those out, I'll still have 1 Q on the top over here. So before multiplying, I like to rewrite the fractions because it's a little bit hard to see after all of those ticks. So I have 4p squared over 1 times 2q, and I don't write the 1, over 7 with no p's. Okay, now I'm going to multiply them together. Top times top, 8p squared q, all over bottom times bottom. Now if we're going to state the restrictions, we want to look for each of the denominators. So these denominators, things were already canceled out, but that's okay. We'll take a look at both of them. 9q squared cannot equal to 0. That means that when I divide out the 9, I'm going to get q squared cannot equal to 0. Then I'm going to square root, and q cannot equal to 0. So that's one restriction. Q cannot equal to 0. The other one, 35p squared, cannot equal to 0. So again, I'm going to divide out my 35, left with p squared cannot equal to 0. Once I square root, I'm going to get p cannot equal to 0. Just going to extend this a little bit. Therefore, p can't equal to 0 and q can't equal to 0. So those are my two restrictions for my variables. The next one, before we start canceling things out, it looks like we're going to have to factor. So I'm going to quickly factor the top and the bottom of the first fraction. Two numbers that multiply to 3 and add to -4 are -3 and -1. Two numbers that multiply to -12 and add to -1 are -4 and +3. Then we're going to multiply. Notice that I use a dot instead. The reason I don't use an x is because someone might accidentally mix up my x variables. So when I'm dealing with x's, I like to replace the multiplication with a dot instead. Okay. Everything is nicely factored, so we're going to start to break down things. Something from the numerator that matches a denominator. Numerator, denominator. It looks like everything that's left on the top is just an x minus 1. And then on the bottom is an x plus 3. When we start to list the restrictions, make sure that you do it before you start crossing things off. So we're going to do it from this step and not the step below. x minus 4 cannot equal to 0. That means x can't be positive 4. X plus 3 can't equal to 0, which means x can't equal to negative 3. This one also has a denominator, so we want to make sure that we also state that restriction. X minus 3 can't equal to 0, and that means x can't be positive 3. So we have 3 restrictions in this case, and again, we're just going to list them out in order smallest to largest. So x can't be negative 3, 3, or 4. That's basically multiplication. Let's take a look at division now. If we have a fraction and we're dividing it by another fraction, recall that the rule is you're going to flip this one upside down to become 9 over 10. The first fraction does not flip, but then the division changes to a multiplication instead. So you're just multiplying by the reciprocal. And that's what we're going to do in each of these examples. So I'm going to rewrite this first with the multiplication. 4a squared b3 over 11c multiplying 55c squared over 6ab. Now that they're multiplying and I've flipped the second fraction, I'm going to start to break things down. So it looks like the 4 and the 6 can be broken down to 2 and 3. The a's can be broken down. That means I'm going to have one a up here. And the b's are going to be broken down and I'll still be left with 2 b's at the top. Now these two can be broken down, divided by 11. I'm left with 1 and 5. And then if I break down the c's, I should still be left with 1c on the top. I'm going to rewrite this just so that I can see it a little bit more clearly. We have 2 with 1a and 2 b's all over 1 and no c's. Multiplying 5 with 1c over 3 and no other letters. Top times top gives me 10ab squared c all over bottom times bottom. Now let's talk about the restrictions a little bit. Here's a denominator right here that we can find a restriction for. So 11c cannot equal to 0. When I divide both sides by 11, I get c as not being allowed to be 0. Here's another denominator that we should find a restriction for. So 55c squared can't equal to 0. Divide out the 55, and I get c squared can't equal to 0. And then square root both sides, and you get the exact same restriction as before. So that looks like all the denominators, but there's a hidden denominator. Once you've flipped this upside down, you've now been given a new denominator, one that you haven't accounted for. So make sure that you also solve for that one. 6ab cannot equal to 0. And now that we have two letters, it gets a little bit more tricky. So I'm going to divide out the 6. And let's just say I want to solve for a. So if I solve for a, I'm going to divide by b on both sides. And that means a cannot equal to 0. If I wanted to solve for b's restriction, I'm going to divide by a on both sides, and that means b can't equal to 0. So in this case, we have 3 restrictions. A can't be 0, b can't be 0, and also c can't be 0. All right, the very last one. This one requires us to factor. So we have x and x. Positive 2 times positive 5 gives me positive 10 and adds to positive 7. And then on the bottom, we have x and x. And two numbers that multiply to negative 4 and add to negative 3 are negative 4 and positive 1. Then if you want to, you could actually flip the second fraction right away. Remember to change that division into a multiplication. So now we can start to break things down. Numerator and denominator. Numerator and denominator. And I'm left with x plus 5 and x minus 4. For the restrictions, it wouldn't be convenient to look over here and solve for x. Instead, I would look at the same denominator but already broken down. So from this denominator, x minus 4 cannot be 0, which means x can't be positive 4. Over here, x plus 1 can't be 0, which means x can't be negative 1. We have the original denominator over here, which was the same as this one, so I don't technically have to solve for it again. But recall that if we flip it, it gives us an additional denominator, so we have to solve for that one. So x can't be negative 2. There's 3 restrictions, and we're just going to list them all out, smallest to largest.